11 definitely إن شاء الله. فلسه ما سويت ولا أعلنت عنه ولا شيء، بس I know that there will be quiz. I want to give you 2 quizzes الأسبوع هذا والأسبوع الجاي إن شاء الله، في 11 والأسبوع اللي بعده في 13. عشان كده we want to be prepared from now. طيب
دكتور
نعم.
بس تبي شور دكتور يعطيك العافية، يفضل انك ما تسوي الخميس، جدا مضغوطين في الخميس يعني بس عشان.
طيب لا حول الله تعالى. طيب بسم الله الرحمن الرحيم. In last lecture on chapter 11 we discussed the intermolecular forces, and we said that there are 3 important intermolecular forces. What are these 3 important intermolecular forces? These are for molecular compounds. What do you mean by molecular compounds?
Doctor, did you share your screen?
Oh yes, I okay, just check now. Molecular compound, I said last time, the intermolecular forces between molecular compounds. What do you mean compounds?
Non-metal with non-metal.
Exactly. Non-metal with non-metal. All right, good. These are called molecular compounds. What are the 3 important forces? These are not very strong. Not very strong. These are not strong, not very strong. I mean, they are strong somehow, but not very strong. What are these 3 important forces?
And pole.
Yes. First one is hydrogen bond. Second one is polar. And third one is called or dipole it's called. What's the third force? Yes. Dispersion. Dispersion forces. There is another name for this force. What is it called?
There was
London forces. Or what's the other name? Van der Waal forces. These are the 3 names are acceptable names for the third kind. Okay, the hydrogen bond, it takes place where?
between hydrogen and oxygen and nitrogen or
yes, 3 important systems: nitrogen, oxygen, or fluorine. Yes, and the hydrogen must be what?
Must bond to this
directly bonded to them. Like, yes, that's true. Okay, how about polar or dipole interaction? These are bipolar compounds. If we have a compound that's partial plus in one side and partial negative in one side, what will happen? they will have partial negative, partial positive, and these are very, very weak. Very weak forces. And then dispersion forces, where does it occur?
In all elements, all compounds.
All molecules, every molecules. Yes, that's important. All right. All right. I'm not going to go over this. I already discussed these things before. So now let's have this example. What type of forces between CCl4 quickly?
London.
Only London or Van der Waal, London or Van der Waal, same name. Or what's the other name, the most important name? There is a third name, which is available everywhere.
LDF.
Dispersion.
Dispersion, you must memorize this name in particular. Dispersion forces. All right, good. How about CH3? Is there polar in this one?
No.
Non-polar. This is non-polar, so there is no, because it's AB4A0, AB4A0, which is non-polar. Okay, how about what type of forces we have here? All of them. There is the hydrogen bond, there is dipole, and there is dispersion everywhere. So all of them is available in this molecule. Okay, how about this molecule? How about this molecule? Is there a hydrogen bond here?
Yes, but it's hydrogen with
No.
the carbon.
Is there a hydrogen like the dot I put here? Is this
No.
hydrogen?
No.
No, why not?
Because the hydrogen is not attract to oxygen directly.
Exactly. So there is no hydrogen bond. So no hydrogen bond. What type of force is here?
Dispersion.
Dipole. What's the other force that's available here in this molecule? You don't have to think. What is it?
Dispersion.
Dispersion, the third one. I hope this is clear. Good. How about the last one? What type of force we have here?
Hydrogen.
Do we have hydrogen bond?
No.
No hydrogen bond because sulfur, hydrogen is connected to sulfur, not to oxygen or fluorine or nitrogen. Is there double interaction?
Yes, there's.
Yes, there is, because this does not cancel each other. Is there dispersion?
Of course.
Of course, you don't have to think exactly. Good. Also, what did we call this force? This force, what do you call it? Yes. Ion, this is ion, and this is dipole. There is partial negative here. So what will be attraction? There will be attraction between the ion and the dipole. That's why we call it ion dipole dispersion. Ion dipole dispersion. Good. Okay, we discussed about viscosity, surface tension. I did not. I told you, and I'm going to repeat, that this is extremely important You will definitely see it in the final. Okay, you have to memorize the equation, and this is called Clausius-Clapeyron equation. You don't have to memorize the name. The name is not important, but you may memorize it just to know what you're talking about. Clausius-Clapeyron equation, but the important here is the relation. What is P1 and P2? What?
Pressure.
Vapor pressure of the liquid. Vapor pressure of the liquid. Okay, what is T1 and T2?
Temperature.
Temperature.
In what?
Temperature Kelvin.
Kelvin. What's R?
The constant
8.31.
8.1 joule per mole Kelvin. You have to use the one with joule. And what's delta H evaporation?
Enthalpy.
The enthalpy of vaporization is to make the liquid goes to gas. So what's delta H for water, for example, is to say H2O liquid goes to H2O gas. That's the meaning of delta H vaporization. All right? I hope so. Good. Next. Now, we're going to talk about the solid. The first thing we're going to talk about is unit cell packaging, closest packing, okay? And when we have a solid, if we have the atoms very well arranged, we call this crystalline solid. Crystalline means arranged, very well arranged. If they are not arranged, we call it amorphous. Amorphous, not arranged. All right, good. Now, if we have a solid like this one, is it going to be solid, to be crystalline or amorphous?
Crystalline.
crystalline.
Definitely, they are crystals. These are crystalline, and these are crystal straight shape. Okay, let's look at these two examples very quickly and then come back. Yes. Which one is crystalline and which one? This is 1 and 2. Which one is crystalline?
One.
Which, and the other two, what are we going to call it?
Amorphous.
Amorphous. Amorphous. Why? Because you can see the atoms are arranged. Look at one, it's very well arranged. Okay, this is the shape of the water molecule when it becomes ice. First one is H2O solid. All right, H2O solid is crystalline, and you have the crystal like this. Good. Now, have a crystal like this. We call this unit cell. Unit cell. I want you to tell me why we call it unit cell. It's one unit of many units, right? One unit that if you repeat it everywhere, you'll get this one. See, the A, actually, if you repeat A everywhere, you'll get B, right? That's why we call it unit cell. Unit cell is is the it's a basic repeating structure unit of crystalline solid. So if you repeat this, repeat it everywhere, you will get B. Okay. Now we call each point in this thing. So this is called unit cell. I want you to memorize the name. Unit cell. This is called crystalline solid. V is called crystalline solid. Okay, and if you repeat the unit cell, this is the unit cell. If you repeat it everywhere, you will get to the crystalline solid. We call each point here, we call it lattice point. Lattice point. And we call this lattice structure. Lattice structure. I want to memorize the names. Lattice structure, and these are called lattice point. Each point here is called lattice point. You have to have these things. This structure is here is called cubic structure. We have many others structure. All of these solid are known. Don't worry about them at all, except the simple cubic. Okay, the rest are advanced for this course. This is called tetragonal, orthorhombic, rhombohedral, monoclinic, triclinic, hexagonal. These are all unit cells of crystalline structure, but don't worry about it. I want you to know only which one? Simple cubic. What's the property of the simple cubic? A equal to B equal to C. Here is A, here is B, and here is C. And alpha, beta, gamma are all equal to each other, and they are all 90. Alpha, beta, gamma is the angles, and they are all 90. You have to know this. Only this structure. Keep it in mind and memorize it. I hope so. Good. Now, when we have we call the coordination number. Coordination number is number of atoms or points around. It could be atoms or it could be molecule. Number of points. I'll not use atoms because it could be molecule. Number of points around the X, around X, let's say, whereas X is here. So in this case, what you're seeing here in A, how many, what's the coordination number of X? Can you see X?
Yes.
X is this atom or molecule. I don't care. It could be molecule, it could be atom. But X, how many atoms or how many molecules around it? Count them. 1, 2, 3, 4, 5, 6, 7, 8. Exactly. Can you see that? Okay. And then this is how we say these things. When you pack it differently, when you have it inside and you have these things, they're also 8 around it. And this is called, when they are in circle, then there will be only 6 around it. Anyway, this is called coordination number. Coordination number. Also, you have to memorize the name at this time. Good. Now, we have 3 types of cubes, and you have to memorize the name extremely well, very well. The first one is called simple cubic. The second one is called body center cubic. And the third one is called face center cubic. I want you to memorize the name. Sometimes we call this one FCC, BCC, and this one called SC. What's SC?
Simple cubic.
Simple cubic.
What's BCC?
Body center cubic.
And FCC?
Face center cubic.
Base center cube.
What's the difference between them? This is the simple cubic or primitive cubic. Look at it. 8 atoms make the, this is actually, when we draw it small like this, just to represent it for you, the atoms are actually touching each other like this. So this is the real structure. And we draw it like this for simplicity, just to show you how things are. But in fact, they are like this. This is the real structure. And you can see here, there are 8 atoms making the cubes, and they are attached to, attached to each other. Okay, what do we call this? Body center cubic. Why do they call it body center cubic? Because there is atom inside the cube. Can you see the atom inside the cube?
Yes.
Yes. And why did they call this one face-centered cubic? Because this is the first face. What do we have here? This atom, the middle atom here, is exactly on the face, so you can see it. And that's why they call it face-centered cubic. Okay, if these are touching each other here, what this one is R, from here to here, from the nucleus to the nucleus, I'm going to call it A. Then what is R for the simple cubic?
A/2. A/2.
Exactly, R. What do you mean by A, by the way? Is the distance between what?
Between two nucleus.
The center of 2 atoms.
Exactly, the distance between 2 nuclei. And what's R?
The radius of atom.
Exactly, radius of the atom. So A/2. Is this clear? Now, if this is this nucleus, and this is the nucleus, they are all in the face, and this one is this one, and this is the distance. Then, if this is A here, then what's the distance from here to here?
Two A.
No, wrong. If you have a triangle, this is A, this one is A, what will be this one?
It's like Pythagoras.
Yes,
So a square plus a square.
exactly. So what is this distance from here to here? This distance, it will be A square root of 2. Why? Because this distance equal to A square plus A square, and then we have to take the square root. So it is A square, I will call this one at this time X. X is equal to A square plus A square, which is 2A square. This is X square, of course, according to زي ما قلت نظرية فيثاغورس. All right, so what will be X in this case?
Square root of 2 a square. So a square root of 2.
A square root of 2, exactly. And what will be R in this case? A square root of 2 divided by 4. Why did they divide by 4? because there are 4R, 1, 2, 3, and 4. Can you see it?
Yes.
I hope you can see it very well, because I can ask you in the quiz or the exam to tell me what if I give you A, this distance here, and I ask you to find R. If it's simple cubic, you should just simply take A over 2. If it's face-centered cubic, it is A square root of 2 divided by 4. If it's face-centered cubic. And if it's body-centered cubic, I want you to memorize it without thinking. R is equal to A cubic root of 3, square root of 3 divided by 4. So it's very similar to face center, but this one is 2 and this one is 3. I want you to memorize it like this. Okay? So can you tell now the relation? You have to memorize this relation. Very important. What's R in simple cubic? A over 2. What's R in face-centered cubic?
A square root 2 over 4.
Over 4. What's R in body-centered cubic?
A square root 3 over 4.
You have to memorize these relation. You have to memorize them very well. Good. When we pack atoms, we can, when you put oranges in box, تخيل عندك صندوق وتبغى تحط فيه برتقال. How do you put them? You put the first layer like this, and then you put the second layer like the red. This is called packing. تعبئة. Packing means تعبئة. All right, and then you can pack it, and then you start the third layer one more time, so it will be A, B, A, B, A, B, and continue. Is this clear? This is one type of packing. The other type is, this is called now hexagonal close packing. If it's AB structure, then this is called hexagonal close packing. Hexagonal close packing. If it is ABC, this is called cubic close packing. Cubic close packing. And سكروا المايك بس افتحوا وقت اللي يتكلمون عشان ما يطلع اصوات هذه. Okay, if you put AB, when you file them, then this is called hexagonal close packing. And the blue, there will be يعني كأنه 3 colors, blue بعدين red بعدين نرجع زي البلو فوق البلو exactly, and this is called hexagonal close packing. Or if you rotate it like this, I have, by the way, in the extra, you have a better view of this one. This is called cubic close packing. Cubic close packing. The difference, you have to memorize it this way. Hexagonal how do we pack it? A, B, A, B, A, B. How about cubic close packing?
ABC, ABC.
It would be ABC, 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 and so on and so forth. Is this clear? I want you to memorize these two names: hexagonal close packing and cubic close packing. Hexagonal close packing and cubic close packing. Now, I want you to notice one thing also. Let's go to here. If you put, if we have this cube, this is a cube, all right? And I want to put an atom here. Okay, then this cube, as we say here, this cube, if this is one of the cubes, there is another cube here. So let's talk about this atom here. How many cubes are sharing it? This cube is sharing it.
4.
This cube is sharing it. What else? The one behind is sharing it. And the one behind is sharing it. And the one above it is sharing it. And the one above it is sharing it. And there is 2 in front that we cannot see. I want you to go back to this one and tell me, if we have this atom here, how many cubes will be sharing it? How many cubes?
3.
4.
There is one beside it, right? This thing. Right?
8.
There is one behind it. That's 1, 2, 3. What else? And then one, and then one in front of it.
6.
And one in this side, in front from this side. What else? One from front this side. And one just touching this cube. So actually you will find that 8 cubes will share the corner atom. If you have one atom in the corner, how many cubes will share it?
8.
8. You have to know this. 8. This means the atom is only 1/8 in each cube. صح؟ متابعين يا شباب؟ احنا مركزين على الاتم هذه الاتم اللي بسميها اكس. اكس موجود في كم كيوب؟ احنا قلنا كم كيوب والشيرت؟
8 cubes.
8. اذا اكس ثمن في هذا الكيوب وثمن في الكيوبز الباقيه، عشان يصير ثمن وثمن 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 في 8 كيوبز يصيرون اكس. صح؟ هي 1 اتم. صح؟
Yes.
واضح؟ ممتاز. إذا لما يكون عندنا سمبل كيوب زي كذا، سمبل كيوب زي كذا، هذول كلهم كورنر، فكم موجود من الاتم هذه داخل الكيوب هذا فقط؟ 8. صح؟ وهذا 8 وهذا 8 1/8 1/8 1/8 1/8. What does that mean? How many atoms are available in the cube?
8.
8.
No, in this
One.
cube only.
1.
It's only 1 atom. There are 8 corners. Each one is giving 1/8. What's the total?
1.
1 atom per cube. Is this clear? واضح يا شباب؟
Yes.
واضح بس العد شوي يلخبط يا دكتور.
يعني نرجع مرة ثانية زي ما قلنا. هذا مرة ثانية للكيوب. any cube. Let's take this cube. And I told you now, you don't have to know exactly how, but you can try it at home and put something in this corner and see how many cubes you can put. As I said, if we have 1 atom, we're going to call it X here, available in the corner here. How many cubes can share it? I told you there will be 8 cubes. 8 cubes will share X. كلير؟ ايش معناتها؟ يعني اكس تعطي 1/8 اونلي للكيوب، لكل كيوب، لانه اكس موجوده في 8 كيوبس، each cube will take 1/8 x. صح؟ واضح يا شباب؟
اي واضح الحين.
لانهم 8 cubes are sharing it. Now, if I have 8 atoms, 1, 2, 3, 4, 5, 6, 7, and the one which is here in the back, you cannot see it, but it's 8. If I have 8 atoms, each one is giving 1/8. How many atoms will be in the cube? 8 times 1/8, which is equal to what? 1 per cube. So in simple cubic, there will be 1 atom per cube. How about if it's face-centered cubic? If it's face-centered cubic, how many cubes can share it?
2.
Only 2, exactly. So how much will be in this cube and how much will be in this cube?
One over 2 for each.
1/2 for each, exactly. Now, if I have, now, let's talk about face-centered cubic. وبخليه بس بوريكم الوجه الأول. عندنا 6 أوجه بالصورة هذه. الفيس center, there is one in the middle like this one. All right, and this cube like this one. Now, how many? We have 6 faces. Each one contain one of this one. So how many atoms are available in the cube? There are 6 faces. I'm talking about the one which is X now, the middle. There are 6 faces. Each face كم فيه من ذرة؟ أنتم تشوفون هنا كم فيه؟ في ذرة كاملة ولا نص half X. So how many atoms will be in the
3.
cube? In the face. صح. صح. طيب.
Yes.
والكورنر كم تعطي الكيوب الواحد؟
1/8.
1/8. فعندنا 8 في 8 مثل اللي قبله.
4.
8 في 8 كم؟
1.
1. فيصير المجموع الموجود في الفيس سنتر كيوبيك 4 atoms per cube. وبعدين آخر شيء البادي سنتر كيوبيك، آسف، البادي سنتر كيوبيك لما تصير في داخل لو كان عندنا كيوب واحدة موجودة داخل الكيوب، كم كيوب will share the one which is in the middle؟ none. صح؟ لأنه في وسط الكيوب صاير ما في ولا كيوب is sharing the one in the middle except this one، فتصير one atom in the cube. Okay, I want now to summarize things for you. This is very, very important. We have to memorize this and know it very, very well. What is this? I'll tell you the following, and if you don't understand it, I don't mind. You memorize it and memorize it very well. We have 3 important cubes. I want you to memorize the name of these 3 important cubes. What are the name of these 3 important cubes? What's the name?
Simple cubic.
Simple cubic. What's the other one?
Body center cubic.
Face centered cubic. And the third one?
Body center cubic.
Body centered cubic. You have to memorize the name. Okay, now how about to find how many atoms per cube?
Doctor,
In cubic? Yes,
I have a question.
yes.
Is what's the type of quartz?
What?
Yes,
What do you mean?
it's a simple cubic or free or BCC.
No, it's totally different. It's hexagonal close packing. The quartz is not among these. But we are not going to talk about the structure of quartz. We're talking about simple stuff only, which is simple cubic.
Like silica.
Silica is also maybe silica. I don't know. I'm not sure about silica. But this is also, we're talking about only metallic compounds now. Metallic compound, one metal. Metallic compound. metallic elements هذول اللي ينطبقون فقط على الميتاليك elements اللي نتكلم عنهم الآن. How many atoms in the simple cubic? I told you this before and you should know. How many atoms? 1 atom per cube. Okay. How about the face-centered cubic? How many atoms per cube?
3.
4. 3 from the face and 1 from the corners. 4 atoms per cube. And how about body-centered cubic?
2
atoms per cube. Is this clear? Also, I want you to find what is R, the radius. For the simple cubic, what is it equal to?
A over 2.
A over 2. What do I mean by A? A in the cube, if there's a cube, the A is the edge of the cube, A, which is this edge, or this edge, or the one in front. What is the R for face-centered cubic?
A square root 2 over 4.
Exactly, you must memorize this. And what is it for body-centered cubic?
A square root 3 over 4.
You have to memorize this table extremely well. Is this clear? Memorize it. No excuses. Good. All right. Now, as you can see here, this is what I just discussed for you. But now A is equal to 2R. This means R equal to what? A over 2. And here it's written for you A equal to, this is for body-centered cubic, A equal to 4 over R over 3. So what's R? A cubic root of 3 over 4, right? And what's R here?
A square root 2 over 4.
A over square root of 8. Okay. Okay, which is equal to what?
A square root 2 over 4.
Should be, what's the square root of 8? Square root of 8 equal to 4 square root of 4 times square root of 2, which is equal to 2 square root of 2. So, yes. So, R in this case equal to
Well, A square root of 2 over 4.
2A square root of 2 over 8.
2 square root, yeah, 2 square root of 2. I don't know what's the relation. Anyway, as I told you, I don't know. It should be, I don't know how to erase it, but
It will be 2A square root 2 over 8. 2 with 8 would go.
R will be A square root of 2 over 4. You have to memorize it this way. Yeah, it's 4. Yes, yes, yes. Oh, that's why. Of course, it will be, this means I can now, I think I know. It's over 4, not over 8. So in this case, R is equal to A over square root of 8, which is 2 times square root of 2, right?
Yes.
Yes.
This means 2 or, 2 square root of 2 R equal to A. What happens? I'm confused. Anyway, I am confused. Sorry.
Multiply
But
two
You multiply square root on both sides.
Yes. Memorize it this way. R equal to A square root of 2 over 4, as I said, or this way. These are related. I don't know how to make them related, but they are exactly the same. I want you to memorize these things. Good? Good. Now, if we have gold, what's gold? AU. Okay. It is face-centered cubic. Face-centered cubic. This means how many atoms per cube?
4.
4.
4. There are 4 atoms per cube. Okay. And the density is 19.3 gram, 19.3 gram per centimeter cube. This is the area of the cube, or sorry, the area of the density of gold. Okay. Okay. What is R? What's the R? Can you find that?
We divide by molar mass.
Now, first, you have to know the following. Gold, what's the mass of gold? If we have 1 cube, then how many atoms of gold will be there?
Four.
What? 4, because it is
Face-centered.
it's face-centered cubic. There are 4. What's the mass of 4 atoms? Go to your periodic table. Quickly.
196.97.
196.97.
97.
What's the unit?
AMU.
Yes, why AMU?
Because it's for 1 atom.
Exactly. All right. Now, okay. Now, oh yes, I want to erase this. Now, can you change this to gram?
Yes, multiplied by 1.66.
1 gram equal to 6.022 times 10 to the power. Come on. What's this number?
Avogadro.
Number will change it to gram. Can you find from the density the volume?
Yes, divide the density by the
1
grams.
centimeter cube. All right. Divide by 19.3 gram. Gram will go with gram. Give me what's the volume? 4. ضرب هذا تقسيم Avogadro's number تقسيم the density. Give me a number quickly.
$6.78.
6. Who got the same answer? 6 point? 7, 8. I don't know what's the answer, by the way.
Multiply by 10 to the power minus 23.
Who got the same answer?
I got the same answer.
Okay, this is what? Centimeter
Centimeter cube.
the unit. Good. Can we change it to
Armstrong.
nanometer?
Armstrong.
Can we change it to nanometer cube? Oh, okay. What's the, if this is the volume, keep it as it is. What will be A? We know يعني هذا القاعدة. The volume equal to, from A point of view, equal to if A is the edge,
A cube.
then the volume is A cube. Can you find what's A?
Yes.
Go ahead.
Eight point 23 times 10 to the power minus 12.
8.23?
Yes.
8.23 times 10 to the power minus
12.
12 centimeter. Right?
Yes.
Because the unit is centimeter. Can you change centimeter to nanometer?
Yes, doctor.
By 10
One
to the power 9.
10 to the power
7.
7 this time, because it's not meter, nanometer, exactly.
Yes.
What will be the edge in nanometer?
8.23
8.23 times
minus to the power
minus
minus 5.
5 نانومتر. في شيء خطأ، شكلها صغير مرة، شكلها أصغر مما كنت أتوقع. ترى ما عندي أرقام، فأنا معتمد على الأرقام اللي I hope more than one did it and he got. Did you get the same answer?
ايه دكتور غلط.
ليه غلط؟
ايه غلط دكتور. It
What's
is
A?
4.08 times 10 to the power minus 8.
كم إيه مرة ثانية؟
4.07 في 10 أس 7.
سالب كم؟
minus 8.
minus 8.
Yeah, that's much better now. That's much better for me. Okay, okay. So who got the same answer?
Yes.
Okay, good. So this will be 4.07 times 10 to the power minus 8 nanometer. Then what is R? This is body face center cubic. So what's R?
Minus 1, doctor. 10 to the power minus 1.
Of course. I know. Oh, yes. Minus 1. Yes. Nanometer. Or I can say it's 4.07 angstrom. Okay. Then what's R?
A over 2.
No.
A square root 2 over 4.
A square root 2 over 4. Give me the answer. Multiply this number by 2, square root of 2 and divide by 4.
1.43 times 10 to the power minus 8.
1.3, 43 or 3, 4?
43.
43 times 10.
Times 10 to the power minus 8.
Oh, minus 1.
minus 1 nanometer.
Minus 1.
Yes, maybe. 1.43. Let's see what's the answer. 1.44, exactly. 1.44 times 10 to the power minus 1 nanometer or 1.44 angstrom. You know how to do this now?
Yes.
Very good. Now, what we talked about so far is metal crystals. These are only for metal crystals. Metal crystals only. Now, we're going to talk about ionic crystals. Ionic crystals. And I'm going to give you these 3 simple crystals. The first one is NaCl. You have to know it. Everybody knows what's NaCl. What's NaCl?
Salt.
Salt.
Okay. In ionic crystals, usually the anion, what's the meaning of anion?
الموجب.
The positive one. The
Negative,
positive ion.
negative ion. Negative ion. And what's the name of sodium?
Cation.
Cation.
Cation. Or it's what? Positive ion. Positive ion. Usually the anion are taking most of the space. The yellow thing here is which ion?
Cl.
Cl. And the gray? Sodium.
Sodium.
The chlorine is making face-centered cubic crystal. فكم في من chlorine ion في الكيوب؟
Less than.
4. We have to know this. 4. Face-centered cubic. This means 4 ions of Cl minus. صح؟
Yes.
طيب كم إذا في الكيوب نفسه كم في من صوديوم بلس؟ ما نعرف نحسبها. This is something we did not see. How many sodium plus? It must be what? ايش الريشيو بينهم؟ ايش الريشيو هنا لهنا؟
1
إذا كان في الكيوب 4 ايونز of Cl minus كم لازم يكون Na plus؟
4.
4. 4 to 4 or 1 to 1. صح? Which is 1 to 1. Is this clear? This is the shape of the sodium chloride. Now, if this is A here, I want you to be careful here. If this is A, can you see A? What is it equal to this? What's this A equal to what now? I will tell you and then tell me why. 2R Cl minus plus 2R Na plus. Is this true?
Is it 2R and A or 1?
No, 2R Na plus and 2R Cl minus. Tell me
Yes,
لا.
yes.
لأنه هنا نصف قطر وهنا نصف قطر، هنا نصف قطر وهنا نصف قطر الصوديوم نصف
Yes.
القطر هذا بس. All right. I want this about sodium chloride. Very good. This is for sodium chloride. The other one is called zinc sulfide. Zinc sulfide. You don't have to know it, but it's again zinc sulfide. It's face center cubic with sulfur is 2 minus. Then how many sulfur atom is there? Sulfur ions is there in the cube?
4.
4. 4. All right. And how many zinc 2 plus?
Should be also 4.
Why?
Because the ratio is 1 to 1.
1 to 1. And then it must. This is the sulfur atoms, and these are the small thing is the zinc atoms. Can you see it? It must be 4 to 4. And these 4 are inside the cube. Very good. The third one is هنا قال لك okay. Now, the edge length of NaCl unit. What do you mean by edge length? What's the letter that we use for edge length?
A.
A is equal to 564 pm. Okay, can we find the density of NaCl? إذا عندنا A All right. What can we calculate? The volume. What's the volume? Come on.
A cube.
A cube. A cube. طلعوا لي كم الفوليوم بسرعة. أول شيء قبل ما تحولون، قبل ما تطلعون الكيوب، حولوا هذا من PM إلى سنتيمتر عشان نخلي الوحدة بالسنتيمتر. What's the relation?
10 to the power.
Absolutely.
The volume is 1.
Oh, this is
Seven.
sorry. This is picometer. Sorry. This is wrong also. Picometer. What's picometer? 10 to the power 10. picometer. اوكي. فقسموا لي هذا على 10 to the power 10 وجيبوا لي الاي كيوب. What is it?
$1.79
1.79
times 10 to the power minus 22.
times 10 to the power minus 22. Who got the same answer?
Yes, I got it.
Very good. Now, how many Cl minus available in the atom? And the cube? We just said this a while ago.
4.
4. And how many sodium?
Also 4.
4. What's the mass of the cube? 4 Cl زائد 4 صوديوم. كم وزن الكلور؟ كم وزن الصوديوم؟
22.99.
22.99. What's the multiply by this by 4, this one by 4, and give me the answer. What's the total mass? بسرعة يا شباب.
233.76.
200?
Yes, 33.
233? Yes.
0.78. Yes.
0.7.
Exactly.
Okay. What's the unit?
AMU.
AMU.
How can you change it to gram?
Multiplied by
Divide by the Avogadro's number.
Give me the answer.
$3.88
3.88.
multiplied by 10 to the power minus 22.
22 gram. You're sure?
Yes, correct.
Find the density. What's the density? Mass over volume. You have the mass, you have the volume. Go ahead, give me the density.
$2.17.
1.6 actually. I don't know why.
168.
2.17.
2.17, 1.6 or 1.7, I don't know, maybe. Okay, 1.7 is acceptable. Okay, that's how you solve these problems. That's how you solve these problems. Can you tell now? Can you do it? Is it easy?
Yes, easy.
Now, we have, these are, now we talked about metal. These are metal crystals. Very good. The other one is, this one is called, what's this called?
Ionic.
Ionic crystals or ionic crystals. We talk about metal crystals. Now we talk about iron crystals. Iron crystals. طبعا الميتال crystal will be consisting of what? Only what? Only metal. Like this example. For example, if I say gold crystal, what type of crystal is this?
Metallic.
Metal. It must be metal. But if I say an ACL crystal, what do I mean by this?
Ionic.
Ionic crystal.
Ionic crystal. We have a third type of crystals. It's called covalent crystals. Covalent crystals. And this one, there are certain compounds, and I want you to know only three important compounds. These are, one of them is diamond. تعرفون من ايش تكون الدايموند؟
Carbon.
Carbon.
Carbon atom. اوكي والجرافايت
Also carbon.
ايش الجرافايت؟
pencil.
رأس القلم البنسل الاسود، الفحم الاسود حق القلم البنسل هو جرافايت. also يتكون من ايش؟ graphite. This is the graphite and this is the diamond, which is very expensive. These are crystals. They are very, very strong crystals, and these are called covalent crystals. We know them as network covalent, because they are available in all dimensions. The third one that I want you to know, other than this, only these crystals I want you to know. The third one is called SiO2, which is covalent crystal also. It's called network covalent. تعرفون ايش هو ال SiO2؟
No.
ايش كتبت؟
رمل.
الرمل. Sand is the third covalent crystals. طبعا هذول كلهم very strong crystals and they don't dissolve easily. كم درجة حرارة الذوبان؟ كم متى تقدر تذوب الرمل؟
درجة حرارة عالية.
جدا. احنا نستخدمه عشان نسخن فيه الاشياء، صح؟ ما يذوب almost. فهذه
Yes.
I want you only to memorize these.
SiO ولا SiO2 دكتور؟
ايش؟
الأو المفروض كذا ولا O2؟
Oh, yeah, O2. Sorry, of course, SiO2. Yes. ايش هو الشيء الثاني غير الساند باي ذا واي؟ جلاس. الزجاج اللي تعرفونه، اي زجاج هو يتكون من SiO2. بس الساند is crystalline and the glass is amorphous. You have to be careful of this. Okay, but it's network covalent. It's a covalent crystal, but if it's sand, then it will be crystal. If it's glass, which is both SiO2, but glass is amorphous. I want you to, when I ask you, give me example of covalent crystal, network covalent crystal, you should tell me either diamond or graphite or sand. Or if I tell you what type of crystal is diamond, what's the answer?
Covalent crystal.
Network covalent crystal. What's the property of this crystal? It dissolves at what? Very high temperature. Very high temperature. انتوا تعرفون حق ايش يستخدم الدايموند؟
حفر.
للحفر. ليش يستخدم للحفر؟
قاسي ما
لانه ما يذوب، يكسر الصخور وما يذوب، مع انها تتولد حراره عاليه بس ما يذوب، عشان كذا يستخدم. اوكي اوكي. and these are molecular crystals زي الثلج. الثلج this is ice by the way, and this is also, it's called molecular crystals. It's covalent, but it's called molecular crystals. And what's the property of the molecular crystals? الثلج عند درجة كم يذوب؟ ثلج متى يذوب؟
صفر.
زيرو.
صفر. يعني ما تحتاج اي حراره، حطه في الغرفه يذوب. يعني معناته الموليكولار كريستالز ار يوجوالي وات؟
solid. I mean liquid.
They dissolve easily.
Temperature. Very low temperature. All right. Dissolving. Dissolve at very low temperature, usually. Good. The last crystal, we talked about it already, but I'm repeating. The metallic crystal, which we talk about like gold, when we said gold and so on. This is how the metallic crystal take place. The atoms, the nucleus are arranged, and the electrons are around it like this. And the electron are called now, what's the name of it? Yeah, the electrons become like cloud, or we call them electron sea. ايش معنى cloud؟
سحاب.
سحاب. وش معنى sea؟ بحر. اوكي. فالالكترون يصير شكلهم as if you see the electrons become like cloud or like sea, and the atoms, when they lose the electron, they become ion, and they will be inside the sea. كأنكم هنا تشوفون بحر فيه أسماك، فكأن الأيونات صايرين أسماك. This is the ions become like, and the electrons are becoming like, the electrons are the sea, and the ions become like the fish inside it. That's why we call it sea or electron cloud. All the metal crystals are formed like this. They make electron sea, and the ions are inside it like so. Okay, that's the property of the metallic crystals. This is the ionic, which we talked about, covalent, and the molecular, and the metallic. Next lecture, inshallah, we'll talk about these properties and the difference between them. All right, I will stop here, and we talked about this before, so I will start from 11.6 next time, and then since we stop here, we're going to take the attendance very quickly, please.